In this video, we're going to do more problem-solving techniques, and we're going to start with the technique guess and check. Now, this actually comes from the old comic Peanuts. If you've not seen Peanuts, that makes me very sad. You should go and look at any sort of Peanuts comics. But here we go. This little comic, he used to love doing crazy math problems, and some of them are really fun to actually solve. Okay, so here we go. In driving from a town A to town D, you pass through town B and then through town C. It is 10 miles farther from A to B than it is from B to C, and 10 miles farther from B to C than it is from C to D. If it is 390 miles from A to D, how far is it from A to B? Well, I knew it would happen sooner or later. What's the matter? My education has ground to a halt. All right. So if you don't know, that's Peppermint Patty, who's being a little bit of a drama queen and very upset because she felt really overwhelmed by the problem. But here's what's kind of fun. We can kind of create a guess and check way of doing this problem where we just try things. So get your calculators ready. I want you to give this a shot. I am going to just draw a little bit of a diagram underneath here to kind of help me. So here's town A and here's town D. And the idea is they told us that it's 390 miles from A to D, right? So this is 390 miles total from here to here. Okay, so that's 390 miles. And we know we passed through two other towns, B and C. Okay, so we need to figure out how far A is from B. Okay, give it a shot. Try, start somewhere and see if you can figure this out. All right, pause the video and then we'll kind of go through my thinking for this. So the way I would approach this problem is I'd kind of start with them equal. In fact, I kind of drew it that way. I'd say, okay, let's pretend for a second that they all have an equal distance. So if I take 390 and divide it by 3, that gives me 130. So if each of these is 130 miles, they're all equal, right? But they want it to be 10 miles farther from A to B than from B to C. In other words, they want A to B to be 10 miles more than it is from B to C. And then they want from C to D, it to be also 10 miles farther than it is from B to C. Okay, so here's the idea. What I'm going to do is if I want this to be 10 miles further, in other words, if I'm going to make this 10 miles further, so 140, and that be 130. Well, here, that can't stay 120 because that won't add up to 390. All right. I'm sorry, can't say 130. I need to change it to 120 in order to add up to 390. And actually, that works. Those three add up to 390, where there's 10 miles between A and B. B to C is 10 miles more than it is between C and D. So the answer is 140 miles from A to B. And there you go. But you could start anywhere. Grab your calculator, plug in some numbers, give it a try. That's the idea with these, just trying to figure out how to kind of set that up and just try some numbers. All right, I'm going to give you another one that kind of works like that. Let's say this time I am told that two numbers, or let's say find two numbers that multiply to 759, but when subtracted, have a difference of 10. Okay, pause the video, grab your calculator, try to figure it out. See if you can come up with the two numbers that work. And then I'll kind of give you my reasoning and how I use the calculator to set this up. Okay, so automatically, I kind of wanted to be smart about this. I mean, I really could start at the beginning, right? 759. I wouldn't want to divide it by 2 because I know it's not divisible by 2, but 759 divided by 3. And here, I'm going to grab my calculator, and 759 divided by 3 is, oops, I hit the wrong button. 253. I'm like, okay, that's far away from a difference of 10. Okay. So I don't really want to just start with the smallest numbers possible, but the truth is I could. I could start with 3, and then I wouldn't probably try 4 because 4 is divisible by 2, but maybe try 6, right? Because that works with 3. And I'd keep trying numbers until I got there, right? 759 divided by 6. I could use this method where I just keep growing. Okay, that, by the way, gives me a decimal. It didn't work. Okay, so maybe then I would try 759 divided by 9 or so forth, right? That's the idea. Okay, but I want to be smarter than that. I'd rather kind of jump closer to the number I'm interested in rather than just figure that out and use my calculator to help me. So 759, let's see, that's kind of close to 800 or so, or $7.50. So I'm tempted to try dividing by 25. I know it's not going to go in evenly, but I'd like to see what I get when I divide 759 by 25. I want to see how far away I am. Okay. So what I got was 30.36 when I divided that. I'm like, okay, actually, the difference between these two numbers isn't too far. There's only a difference of 5. So I'm kind of like, maybe I'll just try some other numbers, right? Like, okay, I'm not tempted to try 24 because I'm worried that since it's an even number, it's not going to work. But here, let me try 759 divided by 23. Oh, there it is. I got 33. So 23 and 33 are the numbers, because when you subtract those, you get 2. But when you multiply them, you get 759. So fun. All right. So that's guess and check. Okay. The next method I want to look at is called make a table. Make a table. We just start listing out the numbers. All right, you start making a list. Okay, here, I want to read this, though it's a little bit wordy, and I'll kind of summarize the basics of this problem when we go through. Okay, so Sue and Anne earned the same amount of money, although one worked 6 days more than the other. If Sue earns $36 per day and Anne earns $60 per day, how many days did each work? Okay, so here we go. Here's the scenario. Sue and Anne are going to have the same money, but they work different days. We know that one worked 6 days more than the other. Okay, before I write that down, I want to write down the pay. So Sue makes $36 a day, where Anne makes $60 a day. So I can already tell you that the one who's going to probably have to work more is Sue, since she's making less per day, right? So Sue worked 6 days more. Okay, so we're going to make a table, literally going to write down values, and I'm going to probably have to write bigger than what I have here. We'll see. We'll start with Sue and Anne, and we'll go from here. All right. Okay, so day one, or week one, no, day one, sorry, day one. Sue makes 36 and makes 60. So get your calculators. We're gonna do all this math here. It's gonna be fun. All right. Day two. Here, let me give myself a few days and we'll see. Okay. Day two, let's see, we got 72 for Sue, 120 for Anne. Day three, 108 for Sue, 180 for Anne. Day four, 144 for Sue, 240 for Anne. Day five, 180 for Sue. Okay, now I'm going to pause really quick because I see, hang on, let me switch to, now let me use the highlighter. I see that these two are the same. However, that was only a 2-day difference, right? You see that? And it's supposed to be 6-day difference. So I need to keep going. All right, let's do this. Keep going. Okay. So Sue, after day 6, gets 216. Oops, I got to keep filling these two out. Sorry. Okay, so day 5, Anne would have earned 300 that day, and then 360. Okay. Day 7, 252, 420. Now, seriously, pause the video. Figure this out. Keep going until you can figure it out, okay? And then come back. Watch me do this. Give myself a little more space here. Okay, so 252, 420. Okay, and then we have 288 and 480. And then we have adding 36 again gives me 324. Adding 60 here gives me 540. Okay, and then let's see, 324 plus. Okay, that's going to be 3. Okay, pausing here. Hold on. 360, 360. Okay, look, they match again. Okay, so how many days did Sue work here? I got to count it up again. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 days. Where Anne worked 1, 2, 3, 4, 5, 6, 6 days. Okay, so that's only a difference of 4 days. Okay, hang on here. Look, 4 days. So right here, they were 2 days difference. Here now we're at 4 days. So the next one should probably do it. Where they match up again, it's probably going to do it. So for 6 days. Okay, so I'll keep listing it out. Okay, so let's see. This will be 600. Okay, adding 36 is going to give me 396. And then this will be 660 here. Oops. And then this will be 432. And this one's 720. And this one's 468. And this one's 780. Keep going. You may want to do this vertically, not horizontally like this. Okay, 468. Okay, so that's 504. And then this is 840 here. I'm going to stop here for a bit. I'm going to go ahead and keep adding on this side though. 504 is 540. Oh, there it is. All right, 540 here. Hold on. Boop, boop. Those two match. And this was day 10, 11, 12, 13, 14, 15 days. And then she earned 540 in 9 days. I know that because it's one less than the last highlight. And there we go. So Anne works 15. I'm sorry. Sue works 15. Anne works 9 days. And there we have it. Making a table. So much fun. All right. Let's try another technique called working backwards or work backwards. So where we kind of, the way the problem is presented, it makes sense to kind of have to work backwards to do the problem. All right, let me read it to you again, and then we'll kind of write down the important information. Sue Ellen and Angela both saved $51 for their family trip to the coast. They each put money in their piggy banks on the same day. But Sue Ellen started with $7 more than Angela. From then on, Sue Ellen added $1 to her piggy bank each week. Angela put $2 to her piggy bank each week. How much money did Sue Ellen put in her piggy, or sorry, how much money did Sue Ellen, oh yeah, have in her piggy bank when they first started? There we go. Okay, so here we go. We have Sue Ellen and Angela have saved $51, both of them each. All right, now here's what we know. Sue Ellen started with $7 more. All right, and then we know that Sue Ellen put $1 in each week. All right, $1 per week. where Angela had $2 per week. Okay, so I want to work backwards from 51. Okay, so here, let me start with both of them. So here's Sue and here's Angela. I'll abbreviate. Okay, so they both started with $51. Here, I'm actually going to give myself a little more space. 51. Okay, so let me switch colors here to the green. Okay, thank you. Oops. Okay, so she's going to have $1 less is $50, 49, 48, and so forth. Okay, so that's 1 week, 2 weeks, 3 weeks prior. Okay, so for Angela, it was 49, 47, 45. Okay, the difference between them. So the difference between these two numbers is a difference of $1. But between those two, it's $2. Here, let me just, I don't need the arrows. So difference between those two is $1. Between those two numbers, 49 and 47 is $2. Between 48 and 45 is $3. Okay, we get it. So we have to go till we get to 7, right? 4, 5, 6, 7. Okay, so here we go. So this should just keep going down. 47, 46, 45, 44. Okay, this one's going down by 2s. So 43, 41, 39, 37. And they wanted to know how much Sue Ellen started with. She started with $44. Angela started with $37. And there you go. That's working backwards. Let's try one more just to kind of make sure we feel good about it. Okay, so Kiko had 6 more red tiles than yellow tiles. Let me write that down. Kiko had 6 more red tiles than yellow tiles. So she gives half her red to Amelia. And then she gave half her yellow to Ramon. All right. If Ramon has 7 tiles, how many tiles does Kiko now have? All right. That is the word now. Okay. Now have. And that's a weird looking V. Okay, there we go. Pause the video. Try it. Work backwards. See if you can figure it out. Let's go ahead and I'm going to step through it then, pretending that you did just do what I said to do. Kiko has 6 more tiles than yellow. She gave Amelia half. So we're going to start with what Ramon has. So Ramon has 7 yellow tiles. What that means then is since Kiko gave half of her tiles, right? She gave half. That means Kiko would have 14, right? Because half of 14 is 7. Okay, so she has 14 yellow tiles. Now we know that she has 6 more red tiles when she started, right? So she also has 20 red then. So if I add 6, right? If I add 6 to that, that gives me 20 red tiles, which she then took half of and gave them to Amelia. So Amelia has 10 red tiles. Okay, so here's what Kiko's left with then, since she just basically is going to have the combination of Ramon and Amelia. She has 7 yellow plus 10 red for a total of 17 tiles. And there you go. There are the techniques we'll look at, or that we kind of focused on to look at these problems.